Hello, everyone, and welcome to today's webinar, Getting Started with the New AI-Accelerated STM32N6. I'm Brian from Elector, and I'll be your host for this session, presented in collaboration with ST Microelectronics. And today we're taking a look at the STM32N6570-DK Discovery Kit. This is a powerful new microcontroller designed for AI at the edge. Whether you're an embedded developer, an AI enthusiast, or just curious about where microcontrollers are headed, you're in the right place today, because joining me are experts from ST Microelectronics. We have Edouard Dulot. He's the head of Edge AI Center Expertise, and he's there with Julian Eterian. And how are you guys doing?
Yeah, we are fine and very happy to be with you today. So it's a great time to introduce you STM32N6 and what we can do with it.
Excellent. I mentioned Julian's there. He's an embedded AI applications engineer specializing in automation and AI development. So they'll be able to guide us through the key features of the STM32N6 and how to get started with AI-powered vision applications. And we've got a very full chat room. A lot of people were eagerly anticipating this. And so keep your questions coming during the presentation, and we'll take questions afterwards. And we'll also talk a little bit about the STM32 Edge AI contest, where you can showcase your own AI innovations for a chance to win part of a €5,000 prize pool. And of course, we'll have the live Q&A session. So stick around and let's get started. Tell us about your product.
Yes, hello everybody. So in fact, we try to speak about the STM32N6. It's a really brand new product because it has been launched in December. And now we've got something which is what we call a superhero for the microcontroller. So let's discover it. First, well, in ST, we've got a large range of microcontroller, from wireless, ultra low power, mainstream, and embedded MPU. And let's say the new STM32 is coming through high performance family. And so we'll find it here. And what is great with this microcontroller is that we used to have some microprocessor, and now in the family of the microcontroller, we've got a microcontroller which is embedded what we call a neural processor unit, so something really dedicated for AI calculation that really boosts, in fact, the product itself. Let's go a little bit further on that and let's discover some applications. So exactly like the MPU, you can really do some vision project with some different application. So let's go and try to discover some. I don't know if it goes like that. Yes. Here is a people detection. So as you can see, you can really see within a frame of 26 frames per second, you can discover and recognize several people in that. As you can see also in terms of weight, it's a very small weight of product with some application like smart doorbells or different occupancy. Here is another thing which is very interesting, is the pose estimation, again with 26 frames per second. On this, you can really create and discover how people are reacting. As you can see, it's quite fast in terms of reaction. So you can really do some kind of behavior analysis, activity monitoring, or other for detection. Here is something that where we have got a lot of application is really the palm detector and hand on mark. So as you can see, you can really see all the movement of your hand with all the finger and all the part of the finger. So that could be really useful for touchless HMI or smart application like in industry. Okay, and so to do that, we've got this brand new STM32N6. Well, one of the main key things of the product is the number of gigaops. So it's more than 600 gigaops that you can use. In this product, there is also the ARM Cortex M55. As you can see, the core mark, it's 3,360, which is really a high score in MCU. And you can have also in this project very nice RAM with 4.2 megabyte. And something which is also very interesting for all application of image is this ESP, so this dedicated image processor, on which you can do everything embedded directly into your microcontroller. And so have really some very nice things to do with graphics. And as a lot and some MCU, you've got also all the feature for security. So if we look a little bit more in detail, so the M55 is clocked at 800 megahertz, which is something which is very strong. And you can see all the external memory, camera pipeline, all the stuff that you can use. Either for audio also application. It's something that is very interesting also. Let's see a little bit more. So what is bringing this Tera ops? It's used to have with only when it was only a STM32 core. The load was only, let's say, a linear load that you can use. But now with this neural art accelerator, you can make some parallel calculation. So it's really dedicated for neural network activity and calculation. And so we see a little bit with, let's say, pose estimation, but okay, for object segmentation and localization, you can have something with a very nice efficiency combined with a very low power of the MCU. So this is something really interesting in terms of reflection of application as how can I create a product with nice precision and very low consumption. So if we look to the field which is open with this new product, okay, there is the drone where you can really imagine some very nice stuff for the vision, where all the calculation will be done into the drone. So you will save a lot of battery of connection. Okay, of course, smart industry and smart home with some nice camera that can see like the doorbell we're talking about to recognize the person, but also some application with, for example, license plates recognition for a car. Or maybe in the retail, if you want to recognize some fruit, vegetable, or whatever. So that could be something also very interesting. For the robot now, big market on robot, which is interesting. Robot collision detection. Maybe you have seen in some application that now you can recognize some object, and maybe the robot can help you to clean the room. Or even with personal electronics like wearable, we've got now something with glasses, next generation of glasses, connected glasses, or let's say intelligent glasses, where you can recognize your hand and the movement that you do with your hand, and also help you to take some decision on an object that you are looking for. So for that, we have created some different, let's say, development boards. One is a Nucleo N670-Q, and the other one is the one that you will use on the contest, on the elector contest, which is the one with a screen and a camera. So for that, it's a very ludic, a very good, nice playground to discover the N6, because it opens a lot of possibility to imagine some application, and also we've got the B-cam, which is a very nice camera to do different creation and different applications. Okay, this is of course all the camera which are compatible, not only because the N6 is also compatible with any camera of the market, so you can really let's say open your creativity and think about different applications. Let's go and see a little bit what do we have in terms of software. We speak a little bit of hardware. Now let's have a look on software. Where Julian will show you how to start with the software. But let's see. Let's have an overview for what we have. So the good thing is it's really a complement to to a lot of open source framework and partner solution. As you can see, we've got in our tools in STM32Cube framework some tools for evaluation, for hardware configuration, for application. We've got also some tools to make some tests when you're online, even if you don't have a board, but you can make some tests. So a full, let's say, set of framework of tools which can be very interesting. And when you will start, the idea is we've got what we call a model zoo. So this is a pre-trained application that you can use. So even if you want to start very quickly, and we'll see how to do it, there are some let's say almost ready to use frame that you have to get retrained, but you can start with that, or you can bring your own model with created through Keras, PyTorch, TensorFlow, or NMX, and you can use at that time, in the second time, STM32Cube AI, which will help you to, let's say, compact your code to put it into your microcontroller, to optimize it, to put it in your microcontroller. So now the floor will be for Julian. So the idea is really to let's imagine plenty of application. Here's some example, but of course it is not limited. We'll be very happy to help you also in this creativity, but this N6, it's a very nice playground, and so let's discover it a little bit more. Brian, if you want maybe to add something.
Well, that's very interesting, and the audience is very excited as well. We've got a lot of people. I'm looking at South Africa, Brazil, Wyoming, USA, Greece, Dresden in Germany. So yes, indeed, as the comment says, yeah, how nice that engineers from all around the world are participating in this webinar. So yes, keep the questions coming. And we've already had the question, will the presentation be available? Yes, it will. After the webinar, we will put it on our website on the registration page where you'll be able to download it. Julian?
Yes, let me switch presentation. So this was a first presentation about the hardware. And in my case, I will show you how you can get started with AI with a simple tool that we call ST Model Zoo.
Okay.
Let's go.
Awesome.
So, as Edouard said, the N6 is really a good discovery board for AI application. And one of the tools that could be useful for you is the ST Model Zoo, because it will help you to easily start. So when you want to start to do an AI application with the N6, you have to ask yourself multiple questions, like where to get the models, how to train a model, and obviously how I can embed this model on my N6. And for that, we have multiple tools in ST, and one of them is the ST Model Zoo, which is composed of two GitHub repositories. One is the ST Model Zoo that contains a lot of models for different use cases, so you can pick and download this model, and we will see that you can also bring your own. And we have the ST Model Zoo services, where you will find scripts to retrain model, benchmark, and quantize models, but also deploy them directly on the STM32N6 for multiple use cases. But as I said, it's either you came with one of your model or you pick one from the ST Model Zoo. The Model Zoo services is only tools to help you to be faster. So just a quick word on the tools in ST, because it can be quite confusing. So we have something called the ST AGI Core, which is a tool that will convert Python models to embedded C code models. And we have multiple tools around that will use the ST AGI Core in background, such as STM32Cube AI, which is a plugin in STM32Cube NX. It's a user interface that will ask you to upload your model, and it will generate in the background with the STAGI core the file needed to generate a STM32Cube ID application. We also have an online tool called the STAGI Developer Cloud. It's the same idea. You can upload a Python model and quantize it and also convert it directly online, also thanks to the STAGI core behind it. And for the model zoo, it's the same thing. We have a part using Python script to train, quantize, evaluate, and so on the model. But when you will convert the model to C code and put it on the STM32N6, it's also thanks to the STAGI core. So a general idea of how the ST models will work, we will see in detail later, but the idea is you pick a use case and then you will edit a config file and to define what you want to do. So you want to train a model, what model with what data and so on. And then you will use a Python script that will run what you defined in this config file. So here are the use cases available in the ST model zoo with the script to train, quantize, and deploy application directly with one script. So we have audio event detection, image classification and posture, human activity recognition, instance and semantic segmentation, object detection, pose estimation, and speech enhancement. So you have a few examples in here. So the first thing you will need to do is to define which kind of use case you would like to do. And then another important point are the operation modes. We will see how we use them later. But in Model Zoo, you can do multiple things. You can train model, as I said, evaluate it, quantize it to make it smaller, do prediction, benchmark its size and inference time directly on the microcontroller plugged to your PC. And we can even deploy a whole application thanks to getting started that we prepared and that are compatible with the Model Zoo. You also have what we call chain operation mode that do multiple things at once. So for example, the first chain is the chain TQEB, which means chain training, quantization, evaluation, and benchmark. So to understand what the Model Zoo does is like this. So you will bring your data and your model or one from the Model Zoo, and you can train, quantize, and evaluate it. If you do that, it's only using Python script that are available in the Model Zoo. But if you want to go further and benchmark a model on the board and deploy an application, it's where we need the STAGI cores I explained, and the STM32Cube ID that will build the project and then flash it into your board. That's why to set up Model Zoo, we need to do multiple things. It can seem complicated, but it's very easy to do. The first thing you need to do is to install Git to clone the repository ST Model Zoo services. Then you need to follow the before you start documentation. It's just a matter of installing Python libraries. Then to be able to flash directly to the N6 runnable application, you need to download the N6 getting started application in st.com. We could not provide them directly into the GitHub because of export control. So you need to download them and copy paste them in the Model Zoo as explained also in the documentation. And then you need to install the STAGI core with the NPU part for the NPU computation of the N6. As I said, it's the part that will convert your model to C code. Don't worry, it's Model Zoo that will do it on its own. You will just need to link the path. And you also need to install STM32Cube IDE because it's the tool that will generate the project, create the binary, and flash it directly into your board. So I can showcase in just a minute what I mean by this, just to make it a little bit less scary. So if we take this, so you will need to go to GitHub and clone this repository. At the end of the introduction, you will find the before you start explanation. So as I said, first you clone the repository, then you will need to create a virtual environment to install all the needed libraries, following the commands that are written here. And the last thing is, as I said, you install all the required libraries that Model Zoo will use to work. Then you need to go to st.com to download the getting started application that will serve as a base for all the application that ST Model Zoo is capable of flashing directly into your board. You need to make a request you will receive an email containing the zip file because of export control again. Then you just need to look at the documentation on how to use this getting started application in Model Zoo. It's just a matter of downloading them, unzipping the file, and copy pasting it into the repository. And lastly, you need to get the STAJL core for your OS and the NPU add-on. You also need to do a request here. You will download the zip, download the installer, and in the installer, it will ask you to link the zip path, so you can install the whole tool. And then you just need to install STM32Cube by just installing the tool again for your own device. So if we go back to the presentation, now that I explained the theory of how to use it, we will see how we can, let me just put it in big mode, how we can use it. So after installing Model Zoo, you will end up with a folder containing all this folder. So you will have the application code, which is the N6 getting started application that you copy and paste in the folder. For each use case, you will have a folder, and all the folder works the same way. Just a few seconds, I will explain that. And you will have the STZoo folder containing the libraries used by the Python script. So let's say you want to do image classification. You will double-click on the image classification folder and end up with this structured folder. You will have first the dataset folder where you will put your dataset. Depending on the kind of use case that you do, you will have different format of dataset. For example, in image classification, you need to create a folder per classes. So let's say you want to classify dogs and cats. You will create a folder for dogs with image of dogs and a folder for cats with image of cats. Once you do that for the dataset, it's done. Then you need a model. So you can, as I explained earlier, get one from the Model Zoo. In Model Zoo, you have a lot of architecture of models pre-trained on different datasets and also with different input size. They are ready for you to download and to copy and paste here. But if you know how to create your model, or you found something else on the internet, you can also download it and copy and paste it in pre-trained model for you to use it with Model Zoo. Then the next step is to go to sources, and in sources you will find the user config file where you will define what you want to do. I will explain it in a bit. And once you have defined everything that you want to do, you will just run the STM32AI main.py, and it will do what you've defined in the user config. Two other important folders here are the config file example. You can find example for everything that you can do in Model Zoo. So if you want an example on how to quantize a model, you will find one. If you want an example on how to train a model, you will find one, and so on. And you also have the experiment outputs. It's where you will get your trained model, your quantized model, and so on. After running the main Python script, it creates an experiment output, so you can find everything that you've done here. If I sum up, to create an image classification project, you will need to first get the dataset, then get a model, then you define what you want to do by editing the config YAML, and then you activate the virtual environment to be able to run the script. If we make an example, let's say I want to create an image classification model that is able to recognize jellyfish using a dataset. First, you need to download or to create your own dataset of images. Then you go to image classification, you go to dataset, you create a root folder, let's say jellyfish, and a folder for each classes. So you will have classes for blue jellyfish, classes for white jellyfish, and so on, with images in it. Once you have done that, the dataset is ready, you can move to the next phase. The second phase is to find a model. You can go to STM32 Model Zoo and look for image classification model. The models are classified by use case, so you go to the image classification folder, and for example, we can see on the right the kind of model that are available in Model Zoo for image classification. For each of this kind of model, you will find multiple of one, pre-trained on multiple datasets and with multiple input size. But as well, you can also import your own dataset from Keras, TensorFlow, or PyTorch, that are the main framework used for neural networks in Python. You need to import them as either .h5 model, .keras model, or .1NX model. Then the edit of the user config file. So it's where you define what you want to do. The main thing that you will do is to set the model path, so which model you want to use, the operation mode, what you want to do, you want to train, to quantize, to deploy, and so on. You want to put the class name, where your datasets are, which one you want to use, and depending on the kind of operation mode you use, you will also have some part dedicated to that. Let's say you want to do quantization, you will have to set the quantization parameters. And again, you can find example for each operation mode in the folder example user config. So you just have to look at this and copy what is done. A small tip that I can give you is when you will do your project, first try to train a model and get a good accuracy, which means that you may have to change the structure of your model. You may have to do modification to your datasets and so on. And once you have a good accuracy, then you can proceed to quantize it to make it smaller and run it faster on the microcontroller. Make sure when quantizing it not to lose too many accuracy. And when you're done with that, you can then deploy the model. Once you have your dataset, your model, and you have defined what you want to do with the user config file, you are ready to run the Python script. So you can open the terminal, activate the virtual environment, and then run the STM32AI.Python script. And once it's finished, so depending on what you do, it can take some time. Training model can be quite time consuming. You will get in experiment output a folder with everything that you've done. So in this example, I have training curve summarizing what how the training did. You have logs, and you have the model trained. And in this case, I also quantize the model. So I have also a folder for the quantized model. If later I want to deploy the model, I can open again the user config, change the operation mode to deploy, and link the path to the quantized model to deploy it later. If you have any question, we have what's called the ST community, where you can ask question, and in particular, we have the AGI board, where you can ask question, and I will answer your question. Please first read all the readmes that are available in the model zoo. Everything is explained. For the dataset, you will find readme explain how to use them. For the pre-trained model, where to put them, and so on. For every kind of operation mode, you will have a description of every parameter, and so on. So please first read them, and if you still have a question, make sure to ask them on the ST community forum. Now that I have explained the theory, I will do two showcases of the real usage of Model Zoo on my PC. One to show how you could train a model for the jellyfish dataset I showed just earlier. And I will also show you how you can deploy a pre-trained model for Model Zoo in a few clicks using Model Zoo. So if I leave this this presentation, I go to my folder with Model Zoo. So after installing Model Zoo, as I said, you will end up with this folder. And if you want to do image classification, you go to image classification folder. You have what I presented just earlier. If you go to dataset, you will find that I created a dataset named jellyfish. In this case, I've split the dataset in three sub-datasets, one for training, one for validation, and one for test. And if you go to the training, you see that I have one folder per classes, in this case 6 classes, and in each folder you have images corresponding to this class. So here I have only move jellyfish. If I go to the move stinger jellyfish, then I have images for the move stinger jellyfish, and so on. So if you want your dataset, you just do it the same way in image classification, and it should work. Then for the pre-trained model, I downloaded 2 models, but we will use only one from the Model Zoo. I just downloaded the model and put it in the pre-trained models. Now that I have my dataset and my pre-trained model, I can go to source and edit the config file. For this config file, what I did is I went to the example, and I want to do a training, a quantization, an evaluation, and a benchmark. So I copied this example and edited it here. So if I open it, we see that we have a lot of parameters that you can find and understand thanks to the documentation. But the main part here are to set the path to the model that you want to retrain, set the operation mode to define what you want to do, define the name of the classes you want to use. Maybe you don't want to use the mod jellyfish, you can remove it and just use the 5 other. Set the path of the data, and then these parameters are for the processing. I didn't touch them. You have some data augmentation that you can use or not, depending on what you want to do. Then you have parameters for the training. I'll leave you look at the documentation for them. Because I'm doing quantization, I also have quantization parameters. They are also by default. And we also have the path to the STAGI tool. If I later want to do a deployment or benchmark, I need to set the path to the STAGI tool for it to convert my Python model to C code files, and my CubeID path also for it to be able to replace the model in the getting started application by the model that I have, and then flash it directly on the microcontroller. To be able to run it, what you want to do is to open the terminal. So in my case, I can open the CMD terminal. Let me grab it. As I said, you need to first activate the virtual environment. So you can look at how to use it on the internet, but basically you activate the environment, and then you go back to image classification, you go to sources, and then you just have to run the Python script STM32AI main.py. The thing is, training a model can be quite long, so I did it in advance. And after running it, what you will get is a folder that I call example of output in this case. And in my case, you can see that I have a training curve that showcases what happened during the training. You have some logs, then you have the train model and the quantized model. So if I want to deploy it later on, I can open again the user config, change the operation mode to deployment, link the path to this model, and run the main script again. I will showcase an example of deployment this time, and the exact result you get on the STM32N6. So let's say you want to do semantic segmentation, sorry. In this case, I don't want to retrain the model. I got one from the ST model zoo that is already pre-trained to detect people and the background. It's this one. I downloaded it directly from ST model zoo, downloaded it and pasted it in here. And what you need to do again is to go to source and edit the user config. In which case, if we take a look, I have the path to the model. I set the operation mode to deployment. I name the classes that are background and person in this case. Then I have a lot of parameters that are not really used, so you can either comment it or leave them. Preprocessing is not used, data augmentation is not used. We are not retraining the model in here. The only thing we need in this case, and everything is explained in the documentation again, is the tool for the conversion of the model. So you need to put the STAGI path and the CubeID path and the deployment. As I explained earlier, you need to download from st.com the getting started application, because you will put them in the model zoo and it will get those applications and replace the basic model that is on the application with your own model. So if you run this configuration, you will have something similar to this. So I activate my virtual environment like before. I go to semantic segmentation. I go to source. I run my Python script. It will convert your model and modify the basic getting started application for semantic segmentation. And it will tell you that it's ready for you to use the board. You will see that to use the N6, the DK board, you have some boot switch to use. It's explained in the documentation. When you deploy a model, you have to put them on the right. And when you will use the application, you have to put them to the left, which is written here, and to power cycle the board. And once you do that, in my case, you end up with the N6 running the semantic application, as you can see here. So this is the model from Model Zoo that was deployed on the N6 thanks to Model Zoo. If later you want to change the application to segment cars or things like that, you will take a pre-trained model or your own model, retrain it on your dataset, and do exactly what I just did to then flash it on your board and have a running application that is ready to use. So let's go back to the presentation. I think actually it's done. So thank you for listening, and let's now take our time to answer your questions.
Thank you very much for that, Julian. Yes, we do have a lot of questions. It is a fascinating board. It's your first board with AI acceleration. And
yes, indeed.
Before we go to the questions, I just want to take a moment to talk about this competition that we mentioned briefly earlier. There is the URL to visit. So this is the STM32 Edge AI contest, and it's hosted by ST Microelectronics, of course, and Elector. And it challenges developers to build AI-driven edge projects using the STM32N6 Discovery Kit. And it's got a €5,000 prize pool, so you can apply for a free board. And if your project idea is selected, you get a board. And so submit your idea by April 30th. Final projects by September 1st. Winners will be announced in November. These are the basic ideas. Judges will evaluate entries based on creativity, technical execution, and real-world impact. So it's a great chance to innovate and win. And to get more details, all the comprehensive details are here, and the URL is at the bottom of your screen there. Okay, so to go to questions, I'm going to also seek the help of another expert in the room. We have here with us Bartosz Borina. He's the Senior Applications Engineer. So feel free to jump in if any of the questions tickle your fancy, Bartosz. Thanks once again to Julian and Edouard for the presentation, which, yes, slides will be available to download. Just go to the page where on our website, and we will put it on. Let me get that up on screen just to show you which page. You just search for the there we go, the web page for this webinar. Easy enough. Now, first technical question. Harm detection and people detection, does this run in real time on the STM32N?
Yes, it runs in real time because, as I remember well, the frame per second ratio, it was 26 frames per second.
Okay, it's pretty impressive. Questions about the contest, and also here's a question, technical question. What are the best strategies to optimize power consumption when running AI inference on the STM32N6 in a battery-powered device?
Okay, there is a lot of strategies. The first could be to reduce the core clock frequency, both for the MCU core and for the neural processing unit. Of course, it reduces the frame per second, the performance, but there is several low power modes embedded in the MCU in the N6. So we have sleep mode. So for the sleep mode, entering sleep mode, the core clock is stopped while the clocks of the peripherals are active. So for example, you can perform DMA transfers in this mode while core is sleeping. Then we have stop mode. So for the stop mode, the clocks for the cores, for the peripherals, most of the peripherals are stopped, while the RAM content is preserved. And the third one, the most efficient one in terms of the current consumption, it is standby mode. So for the standby mode, all the clocks are off, except some really few clocks, few features like wake up pins, and 80 kilobytes of SRAM content is preserved. So this is an option for the reducing the current consumption. What I can say else, it is very important to highlight that STM32N6 is a flashless microcontroller. It is 16 nanometers technology, so it is impossible to integrate the flash. But we have really huge RAM embedded in the micro. It is 4.2 megabytes, and the execution of the program takes place in the RAM. So you need external flash to upload the binary to the RAM. What means that if you exit, for example, standby mode, you need to upload the firmware again to the RAM.
Great, and I think that answers Terence's question a lot here, what are the power down modes of the N6 and how much power they consume? Another question here.
Okay, so regarding the numbers, there is a lot of the use cases. So I really propose to analyze the data sheet in details. The numbers are given for the both sleep, stop, and standby modes, and also anticipating your question. Because regarding the current consumption of different use cases of the AI model execution, it is impossible to cover all the use cases on our site. That's why we propose you to download the application, allowing you to evaluate the current consumption of your model on the level of the discovery board and Nucleo board. Okay.
Yeah, and like Julian said, visit the forum where you can answer questions there too, but read the READMEs, read the documentation. From Ram, we have a question. Some of the recent computer vision models based on transfer architecture. Is this architecture supported for inference on the STM32?
In fact, STM32N6 neural processing unit is mostly dedicated for the convolutional neural networks. So the main application area, it is vision, computer vision, and we have hardware modules in the NPU supporting the convolution operations.
Okay, and that leads to the next question. So it's mainly convolutional for vision, but there is a question if you could train the neural network with other things like sound recognition or temperature prediction.
Yeah, in the Model Zoo, we have one of the use case that is audio event detection. So it's exactly for that. And for temperature prediction, you can probably either create your own code and train your own model and deploy it. Because you can deploy any kind of model as long as they are PyTorch or TensorFlow. But the Model Zoo provides some kind of use case. So you can do whatever you want as long as you use layers that are compatible with the STAGI core. And for sound recognition, it's already in the STAGI, ST Model Zoo, sorry.
Yeah. Question that I'll answer from Milan. Will a recording of the webinar be shared online? Yes, wherever you're watching this now, you can come back later and replay it. We're on StreamYard, we're on YouTube, we're on a whole bunch of channels. And speaking of recording, you might want to come and watch again if you want to follow step by step with Julian's example. Julian, you said you couldn't train here because it takes long. So you trained in advance. How long did it take?
Depending on the kind of model that you use and the performance of your PC, because when you train a model, you are using your own PC. If you have a graphic card, it will automatically detect it if you install everything correctly. So depending on your graphic card, the kind of model, and how much you train the model, and on how much data you train the model, it will depend. So from few tens of minutes to few hours, depends on what you do.
Okay, just curious, did you run on a graphics card, and which one?
On this PC, it's a laptop, so I'm not sure exactly which graphic card we use, but we have a PC with a RTX 4090. So.
Ah, nice. Yeah, I'm running an RTX 4070 here, which has less memory, but it gets most of the stuff done. Can I simulate the newly trained model locally on my computer, speaking of your PC? Like use a webcam to run it and test it?
With the Model Zoo, we don't have scripts for that. So if you can train a model with Model Zoo and then create your own script to run the model, because the model will be saved on your PC. It's a Dodge A5, H5 or ONNX file most of the time. So if you know how to do Python to do that, sure, but it's not made in the ST model.
Okay. Another technical question. Is the NPU dedicated strictly to processing neural network models, or is it kind of dedicated but freely programmable via SDK?
Okay, as I already explained, it is the main dedication is to support by hardware the convolutional operations of the neural network, and the important point from practical view is a tool set, and I mean the compiler for the NPU, because the STH AI framework, it is just a compiler for the neural processing unit, and this compiler is dedicated for the neural networks currently. So it is from the application point of view, it is currently it is rather not possible to use it as a DSP. However, from the technical point of view, it is possible.
Okay, good answer. It's not possible, but it's possible technically. Question from Francois. Will the documentation, speaking of which, show a list of the supported or unsupported operations for different frameworks, TensorFlow, PyTorch, so that they can design models that can be quantized?
Short answer, yes.
Yes, exactly. I put the link in the slide, so if you download the slide and you go to the last page, you will find the documentation regarding the NPU and the stage AI core.
Yes, and as I said, the slides are not available until after the show. We will put them on the registration, on the news item for this show. Here's a question. Can I use the STMod Plus expansion connector to add a wireless connection?
Yes, why not? I'm not sure about driver. It seems to me it is not ready yet for N6, but we have such a solutions for another MCUs. Like I recall STM32L4 Discovery board with STMod Plus. So it is possible, but you need a driver.
Okay. Question here, if you can have more than one camera on the board, like an extra infrared. I think you can, but there are limitations, right?
In the ISPU, so the image signal processing peripheral, we have 3 pipes. So theoretically it is possible, because we have also 2 hardware interfaces, CSI and DCMI, so the serial one and parallel one. So I think it is possible to combine.
Okay, awesome. And in terms of open source, closed source, Jürgen wants to know, is all software free of charge and open for any usage?
Yeah, exactly. Every tool regarding AI within ST is totally free. And the scripts are GitHub repository, so you have access to everything.
Excellent, that's good to know. Question from Giovanni. Is there any example or application note to have insights on on-device training with the STM32N6?
I'm not aware of such a application note, and also as Julian explained, we need as an input for the compiler for the neural processing unit the pre-trained model, so the knowledge is frozen. We have a solution to train on the device, to learn on the device. So I propose to be familiar with Nano Edge AI Studio. It is automated toolset providing the solutions based on the machine learning.
Yes, it's more for sensing application. So if it's for images, I don't think there is an existing solution for on-device learning for that.
Okay, and I think this question is regarding power over Ethernet. Can you power the board through the RJ45 ports?
If you mean DK board, I mean the development kit.
Yeah,
I don't think you need to use USB-C power supply. Especially practical hint for you, for all of you, especially if you are going to use heavy AI execution, I mean maximum clock frequency for both core and the NPU, and also camera and display. You need good quality USB-C cable. By good quality, I mean low resistance.
Okay, And then a question about the contest. The submission, and this is again to open source and which license, submitted full source code, but with what license? Do you know that?
Yeah, in fact, for the first submission to have your project, which is selected for the board, what is really interesting for the contest is to have the description of your project in detail to see what you want to create. But for the submission, you only need to give your ID, not all full code or everything. It's more the ID which will be selected. So the more detail you give us on your ID, the better it will be.
Great. Now there's a question about combinations from Tibor. Can you combine it with Zephyr or TRS, or must it be only made by the STM32Cube IDE? I'm aware of the complexity of mixing, but in my case, many features are available only in Zephyr.
Yes, we have port for Zephyr for N6.
Okay. Great. You guys know all the answers. Benny wants to know, can you also train on PC Yellow X Nano models and transfer it to the STM32N6?
In the model zoo, we have some YOLO architecture model. Exactly which one, I don't remember. But you should, if you are able to get an NX, in any case, you can use it. So it should be possible.
Okay. Julian, you mentioned the forums earlier. There's a question from Stephen if there are any other communities like Slack.
Not that I'm aware of. It's mainly the ST community.
Okay, so if you missed that earlier, Stephen, you can always rewind later. There is a forum available where you can get help from lots of people. Jörg wants to know if you can improve the model while running it.
I think he's asking if you can do online in-device learning, and one said that no, it's not possible.
Okay.
Not directly in the N6. You have to bring it back to your PC and improve it, and then bring it back to the N6.
Yeah.
Yeah. And could you say anything about GPIO for Alexia? He wants to know if what GPIO is available on the board.
There are a lot of GPIOs available on the board. If you would like to use really a lot of, so I propose to focus on the Nucleo board.
Okay. And from MR, what tools or methods do you recommend for profiling and optimizing AI performance on the STM32N6? Thank you a lot.
We don't have specific tools for that, except what is inside the ST model zoo, so you will have to do it on your own.
Yeah, you will have to use some standard product to do so.
Okay. Here's an interesting question from James. Is there an easy-to-use low-price kit for the chip, something like the ESP32 or the PiPico, those smaller boards? Or do you have one in the works?
I suggest Nucleo board.
Okay.
The one was 56.
And maybe practical hint for all of you. The DK board, so the one shown by Julien, is more dedicated for really AI vision application because you have camera, you have display, while the Nucleo board and on the DK board there is also external PSRAM and external flash. On the Nucleo board you have a lot of GPIOs. You have camera connector, but you have external flash because you need flash. You need flash to put your firmware. External flash, but there is no external PSRAM. So if you would like to implement the graphics, heavy graphics, or complex AI model, I propose to switch to the DK board.
Yeah, and just note that the model zoo is only compatible with the DK board for deployment. So you can train model and so on. It's not related to the hardware. But for the example application that you can flash directly using the deployment mode, it's only for the DK.
Okay. Well, while you were talking, I just showed one of our books on the Nucleo board. So have a look at that on our website. We have more information on the Nucleo boards.
There is also a dedicated N6 nucleo board, which is called, you will see it in my presentation, so when you get the slide. It's a nucleo N657-0-Q.
Great. If you'll excuse my distraction, I'm trying to Google that one. I want to have a look at that myself. From Mike, what are the key considerations when implementing real-time voice recognition, especially in noisy environments, or what tools or methods do you recommend for profiling and optimizing AI? Even if you're more specialized in vision, any insights on that?
I'm not really knowledgeable about that, but the thing is, it's not really related to the N6. So if you look for information about how to train model for such thing, you just need to train it as explained in tutorials and so on, and then bring them to the N6.
Okay. And then you showed us a couple of tools that you use, but final question, part of the question, what tools or methods do you recommend for profiling and optimizing AI performance on the STM32N6?
As I said, for optimization and profiling, it's not really, we don't really have tool for that. We provide tool for beginners to be able to train them, but you can do everything that you want if you know how to do it in Python, and then just bring the saved model and use it. We don't really have tool for that.
Okay. And you guys will be at Embedded in Nuremberg next month, right?
Yes,
So,
definitely yes.
So Andreas, drop in there and have a look.
Yes, we'll be happy to welcome you there, and you will see when you get your let's say you pass to enter the fair, there will be directly into the pass the name of ST and the bit. So it will be very easy to find us.
Awesome. Now we're almost on 1 hour, which was our scheduled hour. Thanks again for your time, guys. A couple more questions we can squeeze in, perhaps. What's the resolution for the time of flight sensor that you use?
I would say there is no limitation. On the camera, we have 8 by on the camera module of the Discovery Bolt. As I remember well, we have 8 by 8 time of flight, but it is high performance microcontroller, so you can use higher resolution.
Okay. Well, that answers that. Just checking. Free discovery kits are decided. This is the question from Tibor. Based on the small forms submission, or does it first have to be created, the project, in the Elector portal? You can submit your idea to the Elector portal. You don't have to share all your code, but put as much detail as you can on the idea. And there's Busha. She says she will see you there, and I will see you there too next month, guys. So I'm glad to know that you'll be there. We've run out of time. We could do one more, maybe. Let's see, Mohammed. When it will be finalized for the recipients of the free discovery kit? Well, the deadlines are on our website. So you have to submit your idea, and you get your board if your idea is chosen, and the winners are submit your idea by the beginning of September, and the winners will be chosen in November. But yes, for more information, let me put up that banner again so you have the exact, you can get all the exact information there on the STM32 contest. So thank you, audience, for joining us and with such passion. And it looks like you're going to get a lot of submissions. I hope you have time to evaluate them all, guys. So good luck to those of you who will be submitting ideas, and I look forward to seeing them. And I want to say thanks to our guests, Julian and Edward and Bartos, for joining us and answering all of our questions. And I look forward to seeing you guys next month at Embedded World in Nuremberg. But for now, enjoy the rest of your evening.
Thank you.
Thank you.
Thank you.
Bye.
Bye.
Thank you and goodbye.